Section 2.3. Combining the rules to solve equations. Section 2.3 combines the ideas presented in 2.1 and 2.2. Because you might be adding, subtracting, multiplying, and dividing all in the same equation, there is a proper procedure to go through. But remember, the basic idea remains the same. Get the variable, usually x, all by itself on one side of the equation. So let's go through and do an example. If you are given the equation 4x minus 5 is equal to 7, I have both multiplication, the 4 times the x, and subtraction, minus 5, in that particular equation. The first step is to get the variable term 4x all alone on one side. In order to do that, the first thing I'm going to do is I'm going to get rid of the subtract 5 by adding 5 to both sides. If I add 5 to the left-hand side, I'm just left with 4x. If I add 5 to the right-hand side, I'm left with 12. So now I have an equation which is the same as the original equation, 4x is equal to 12. Now I'm going to go through the process that I went through in section 2.2. Because I have 4 times x, I'm going to divide both sides by 4. When I divide both sides by 4, 4 divided by 4 is equal to 1, so they cancel. So I am just left with a final answer of x is equal to 3. Always when you get done, take your answer, put it back in the original problem, and make sure that it does work. So if x is equal to 3, 4 times 3 is equal to 12, and then 12 minus 5 does give me 7. So this does check, and 3 is the correct answer. Notice that when I did this, it was more than one step. We call this a two-step problem because first I had to add 5 to both sides, and then when I got done, I had to divide both sides by 4. Sometimes when solving problems, we get used to seeing the x term first on the left-hand side of an equation, and it just seems to make sense. But remember, you can also have the x term come second. And here's an example. 3 subtract 2x is equal to negative 9. If I wanted to solve this particular equation, I'm going to do the same thing. First of all, I have 3 on that left-hand side. I need to get rid of that 3 on that left-hand side. So I'm going to subtract out a 3 on the left-hand side. If I subtract 3 on the left-hand side, I also have to subtract 3 out on the right-hand side. The left-hand side, 3 subtract 3 is gone, and I'm left with a negative 2x. On the right-hand side, negative 9 subtract 3 gives me a negative 12. So now I'm down to a one-step left type of problem. I have negative 2x is equal to negative 12. I'm going to go through and I'm going to get rid of that negative 2, that multiplication of negative 2, by dividing both sides by a negative 2. If I divide the left-hand side by a negative 2, I'm just left with x. On the right-hand side, negative 12 divided by negative 2 gives me 6, because a negative divided by a negative is equal to 6. Once again, when you get done, make positive sure you go back and put your answer back into the original equation and make sure that it works. So I'm going to write that original equation, but instead of the x, I'm going to put in the 6. And I'm going to see if I end up with negative 9. When I do that, I'm going to have 3 subtract 2 times 6 is equal to 12 equal negative 9. 3 subtract 12 does equal negative 9 on the left-hand side. So this does work, and the answer to the problem is x is equal to 6. Remember, it's always possible to have x's on both sides of the equation, and here's an example of that. 9x plus 2 equals 3x plus 38. The goal is to get the x all by itself on one side of the equation. So the very first thing to do is to get the x's on the same side. So I'm going to go through and I'm going to subtract 3x from the right-hand side, which will get rid of it. If I do that on the right-hand side, I also have to do that on the left-hand side. So now on the left-hand side, 9x subtract 3x is 6x. I still have plus 2 on that left-hand side. And on the right-hand side, 3x subtract 3x gets rid of my x term on the right-hand side, and I'm just left with 38. Now I still need to get the x all by itself, so I'm going to get the variable term 6x all by itself on that left-hand side. To do that, I'm going to subtract 2 from both sides. When I subtract 2 from both sides, on the left-hand side now, I'm just left with that variable term of 6x, and on the right-hand side, I'm left with 36. Now, I'm going to go through and divide both sides by 6, because I just want it to be left with the x. 6 divided by 6 gives me 1. On the left-hand side, I have x. On the right-hand side, I have 6. So I have a final answer of 6 for that. I will leave it to you to put 6 back into the original equation and check to make sure that it works, but I think you will find that it does. Here's another problem very similar to the last problem, but this time what I would like you to do is I'd like you to pause this video and I would like you to attempt to do this problem first on your own. When you get done, start the video back up and then you'll watch me as I go through the problem. Okay, hopefully you had time to go through and attempt this problem on your own. I will tell you that even though this problem works the same way, just because we're dealing with negatives, this problem does tend to be a little bit more difficult for some people. But once again, on the left-hand side, I have 2x plus 23. On the right-hand side, 6x minus 5. So I want to go through and I want to get rid of that plus 23 on the left-hand side. So if I do that, I'm going to go through and I'm going to subtract 23 from both sides. If I subtract the 23 from that left-hand side, I end up with 2x on the left-hand side, and on the right-hand side, I have 6x minus. Now I have a negative 5 subtract 23, which is a negative 28 or minus 28. Now I still want to get the x's by themselves. So I'm going to go through and I'm going to subtract 6x on the right-hand side so I can get my x's together on the left-hand side. When I do that, on the left-hand side I have a negative 4x. On the right-hand side, 6x subtract 6x cancels out. I'm left with a negative 28. In order to just solve this for x, I need to go through and I need to divide both sides by a negative 4. The negative 4 divided by the negative 4 cancels out. I'm just left with x on the left-hand side. And then on the right-hand side, negative 28 divided by a negative 4 gives me a 7, because a negative divided by a negative is equal to a positive. Once again, I'll let you go through the check, putting 7 back in for both x's and making sure that the equations, both sides, are equal to the same thing. Here's another problem, and although it might look more complicated, it really is not. You can see that on both sides I have two different terms of x's. On the left-hand side, I have a 7x minus 3x, and on the right-hand side, I don't have x terms that are the same, but I have constants that are the same, the 5 and the 13. when I'm doing this problem, it makes it easiest to first of all simplify both sides. So I can combine my x's. 7x minus 3x is equal to 4x. So that left-hand side is really 4x subtract 2. On the right-hand side, 5 plus 13 is equal to 18. So I have 8x plus 18. Now it's very similar to the problems that I did in the past. And once again, feel free to pause this, go through and see if you can figure out the rest of this, and then come back and turn this back on again. Okay, if you pause this and turned it back on again, hopefully you got an answer. This is how I might go through and do this. First of all, on the left-hand side, I have 4x minus 2. I'm going to get rid of that minus 2 by adding 2 to both sides. When I do that, on the left-hand side, I'm left with 4x. On the right-hand side, I have 8x plus 20. I still need to get the x's on the same side, so now I could subtract 8x from both sides. If I subtract 8x from both sides, on the left-hand side, 4 subtract 8 gives me a negative 4x. On the right-hand side, 8x minus 8x cancels out, and I'm left with a 20. In order to finish this off, I'm just going to go through and divide both sides by a negative 4. So the negative 4 divided by negative 4 cancels out. I'm left with x on the left-hand side. 20 divided by negative 4 gives me a negative 5. So my final answer is x has to be equal to negative 5. There is one more type of problem in this section that you need to be familiar with, and that is when you have equations involving fractions. And here's an example. X over 2 minus 2/3 is equal to 5/6. Now, there's all sorts of different ways of going through this problem, but I would like to talk to you about one way that many people like, and that is to first of all get rid of the fractions. We don't like working with fractions, so let's get rid of them. If I go through and I want to get rid of my fractions, I have denominators right now of 2, 3, and 6. Well, the least common multiple of all those denominators is 6. So one thing I can do is I can go through and I can multiply both sides by 6. Once again, I'm multiplying both sides by 6 because that's the least common multiple of 2, 3, and 6. Now I'm going to apply the distributive property to this. I'm going to multiply 6 times x over 2, and then I'm going to multiply 6 times 2 over 3. So I have 6 over 1 times x over 2. And that gives me 6x over 2, but 6 divided by 2 gives me 3. So that's equal to 3x. I could do the same thing now with the 6 times the 2/3. I'm going to do that over here. 6 over 1 times 2/3. 6 times 2 is equal to 12. 1 times 3 is equal to 3. And 12 divided by 3 gives me a 4. So what I really have is I have 3x minus 4 when I distributed that multiplication of 6. On the right-hand side, 5/6 times 6, it's like 6 over 1. The 6 cancel. I'm just left with 5. So now my equation is 3x minus 4 is equal to 5. I'm going to go through and finish this off, add 4 to both sides. When I add 4 to both sides, on the left-hand side I'm left with 3x. On the right-hand side I'm left with 9. Now I'm going to go through and divide both sides by 3, and I get x is equal to 3. Now, truthfully, I did all this work up here, but I really would not go through and do it that way. I'm going to do it a little bit different way. I'm going to do the same problem over again, but I want you to see really a little bit easier way of doing it, and I'll do that now. So here's that same problem again. I am going to do exactly the same thing at the beginning. I'm taking a look at my denominators of 2, 3, and 6, and I'm saying the least common multiple is 6. So I'm going to multiply both sides by 6. Last time what I did is I multiplied the 6 times the x, and then I divided by 2, and I got 3x. But really, it makes it easier if very first thing you do is you say the 6 divided by 2 gives me 3, and then I'm going to multiply the 3 by that x that's on the top. So I just get 3x. Then I'm going to take a look at the 6 and the 2/3 that I have. 6 divided by 3, 6 divided by 3 gives me 2, and then I'm going to multiply that 2 times the 2 in the numerator, and I get 4. So it's 3x minus 4 is equal to, the other side really works the same way. 6 and the 6 cancel, I'm left with 5. The good thing about multiplying both sides by the least common multiple of the denominators is that I get rid of the fractions. Notice this was the original equation right here. This, 3x minus 4 equals 5, is exactly the same equation because I multiplied both sides by 6 and I got rid of the fractions. Whenever I'm doing a problem with fractions, the very first thing I do is get rid of the fractions because I don't like fractions. And then I have a new problem without fractions, and then I can go through and solve it. Once again, in order to solve this now, I'm just going to go through and add 4 to both sides, get 3x on the left-hand side is equal to 9, then divide both sides by 3. I get a final answer of x is equal to 3. Solving equations with fractions is definitely a skill that many people struggle with. So we'll be working on this for the next few weeks. But let me talk about one more. You can see I have an equation here, and I have denominators of 4 and 3. I want to get rid of the fractions. I don't like fractions. The least common multiple of 4 and 3 is 12. So the very first thing I'm going to do is I am going to multiply both sides by 12. Doing that, I'm going to be able to get rid of my fractions. In order to multiply 12 times the very first term, and the very first term is 3x plus 1 over 4, what I have to do is I am going to say, well, what's 12 divided by 4? 12 divided by 4 is equal to 3. So I have a 3 left over, and I need to multiply that 3 times the numerator. So I have 3 times 3x plus 1. Once again, I went 12 divided by 4 gave me a 3, and I still have to multiply that 3 times that numerator, 3x plus 1. I also have to multiply the 12 times the 2. So 12 times 2 is 24. The left-hand side then comes out to 3 times, in parentheses, 3x plus 1 minus 24. Notice I got rid of my fractions. On the right-hand side, I'm going to do the same thing. I have a 12 and I have 3 in the denominator. I'm going to divide. 12 divided by 3 gives me 4. So I have a 4. I still need to multiply that by the numerator, which is x plus 1. So I have 4 and then in parentheses x plus 1 on the right-hand side. I got rid of all my fractions. Now I'm just going to go through and solve. But I have some parentheses, and I need to be able to combine some things. So the very first thing to do is to go through and use the distributive property and multiply so I can combine things. 3 times 3x is 9x. I have 9x plus 3 because I had to go 3 times 1. Subtract 24 is equal to, I'm going to use the distributive property, 4x plus 4 times 1 is 4. On this left-hand side, I have a couple of constants that I can combine. So I have 9x. 3 minus 24 gives me subtract 21. On the right-hand side, I have 4x plus 4. I want to go through and solve this for x, so I could add 21 to both sides. If I add 21 to both sides, I'm just left with 9x on the left-hand side. On the right-hand side, I'm left with 4x plus 25, combining the 4 and the 21 to give me the 25. Now, I still want to get the x's by themselves, so I'm going to go through and I'm going to subtract 4x from both sides. When I subtract 4x from the left-hand side, I'm left with 5x. On the right-hand side, I'm left with 25. Now, I can go through and divide both sides by 5. If I divide both sides by 5, I end up with a final answer of x is equal to 5. As I say, doing this with fractions is a lot of steps, and we will continue to work on this for the next couple of weeks. As you can probably see, it is really important when doing these types of problems to do them in a systematic, step-by-step approach and write everything down. This is not one of those skills that most people acquire quickly. Practice makes perfect. So we will do a lot of practice. Thank you.